run through a shell method. This is very similar to the one I previously did, where I introduced the idea of shell methods to find volume. This is another example building on the same concept. We're starting with the same bounds as the previous problem, so if you've seen that one, this looks familiar. I'm trying to also kind of set this up from another axis of rotation. That's the piece that has changed here. So we have a vertical axis of rotation, and in this case, we're making something that has kind of a cylinder in the middle, and then it's kind of edged on the outside. So it's like a volcano. It's a crater volcano type look to it, if you will. Again, same idea with that. We have, in this case, it looks kind of like this, right? And we'd be building shells inside of there, right? And it kind of would look like that, right? So we'd go around the back side of that. So we have these little shells of cylinders are stacking in each other continuously over and over again. And we still have our equation, if you will, formula for shells, 2 pi r. And we talked last time about this 2 pi r is the circumference of that shell, of that cylinder that we're having right there. And then we have this height. So what we need here is the distance from here out to there, which is our radius, and then we need the height of that piece. And that's really hard to see because there's so much going on there. So I like to really take these things out and flatten them quite a bit. And when you take the cylinder out, think about, again, a soup can. You take the label off the soup can, you flatten it out on your counter, you get a rectangle. So here's your cylinder, right? And there's your height. And of course, the thing we need to find the circumference of that cylinder, which is the distance all the way around, is 2 pi r, right? That's what this value is. This is the r that we need to find that circumference. And it centers from the axis of rotation to the outside edge. So when we're looking at this one, we're going from here to here, and we're creating that piece there. Now, last time I said we need to first identify what goes in this box, dx, dy. How are we orienting this particular problem? In this one, we're going to do 2 pi times the integration of something times something dx. Yx has to do with how we're counting this. With washers, when we count this way, we'd be slicing across horizontally, and we'd be stacking those things up the axis. So we'd be counting in terms of y's, change in y's. This one, what we're doing is we're changing in terms of x's. A simple way to remember this is it's always going to be the opposite of whatever the washer method is. But the other piece of this is think about how we're stacking these. We're stacking, 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 which means that this stack is going to be on the next piece out from there, which is on the next piece out from there. You're thinking, well, those are in terms of y's, right? Well, how are we defining this thing? What does this look like? So this is an x distance for the radius. And we're going to build this according to the radius because it's not being built according to the height. The height is dependent upon what the radius is. The radius is what's dictating the location of this cylinder, and that radius is a distance of x. Hence the reason why we're doing dx. So when we talk about this radius here, the radius is from the axis of rotation to the outside edge. This is a distance of 2 minus that little distance right there, which is a distance of x. And then the same thing with the height. What's that height? Well, that height is that's just a y value. But we've already defined this needs to be in terms of x. So we need to rewrite y in terms of x. Luckily, we have an equation. Now we have everything we need. And there we go. Okay? So this gives us everything we need. And again, so we're defining this radius in terms of how we're stacking these pieces. We're stacking how far are we from the x-axis. That's an x from the axis of rotation. That's an x distance. If our axis of rotation were horizontal, and we're rotating around this way, well, what's the distance from the axis of rotation to that edge? Well, that's a vertical distance. By definition, that'd be a y. Okay, so this axis here, and then the height is built from there. Okay, I hope this was helpful. Please reach out with comments, questions, and if you want to subscribe, you can do that too. I'll keep you up to date anytime I post new videos. Take care.